All right, y'all. Um, I gotta make sure this is working. I guess it is. So today we're gonna do the 2018 free response question 3 calculator. Oh, it just started. My bad. Today we're gonna do the 2018 AP Calculus exam AB no calculator question 3 of the free response. I've only been doing the no calculator ones because I feel like these ones are harder than the ones with calculator, obviously, because the ones with calculator, all you really have to do is set up the problem and then the calculator does the rest. But if you guys want me to work on the calculator questions, I could do that. Just let me know. So, yeah, so let's get right to it. I honestly think that this year they could give you, because, so obviously with the whole coronavirus thing, they're not going to give you any Unit 8 questions because they assume that you haven't gotten to that point in your learning yet. So they could, I'm guessing they're going to give you something like this because this is one of the first things you learn in calculus. You have to combine your knowledge of derivatives, integrals, second derivatives, and those are fairly simple. Those aren't the questions towards the end of the course. I'm thinking there won't be volume questions, but I made a video on a volume question, an area under the curve question. You can check that out on my YouTube as well. It's using the Washington method. Anyway, so let's get to this. So the graph of the continuous function g, the derivative of the function f, is shown above. The function g is piecewise linear for -5 is less than or equal to x, and x is less than 3. And g of x is equal to 2 times x minus 4 to the second power, for 3 is less than or equal to x, and x is less than or equal to 6. So as you can see, this is going to be an, so let's first note that g of x, this graph that we're looking at, also, I'm so sorry, I tried to do my best, I really did. Yeah, this I don't want to flip back and forth between the between the problem and this too much to look at the graph, so we're gonna use this shitty graph that I made, so I'm sorry in advance. So here's one of the assumptions that we have to make. The graph of g of x, which is here, right? G of x is just f prime of x, right? So the derivative of the function of f is equal to g of x. So this is basically showing us what the derivative of f of x is, right? And our first question here is that if f of 1 is equal to 3, what is the value of f of -5? So we know that if we want to find the value of f, and g of x is the derivative of f prime of x, right? We want to find f of x without the prime, right? So we want to find f of x. Then we need to take the integral of g of x, right? Since g of x is equal to f prime of x, and so the integral of f prime of x is just going to equal to f of x, right? And so we know that f of 1 is equal to 3, and we want to find f of 5. So the way we're going to approach this problem is we're going to first find the area under the curve, because we know from, oops, sorry, we want to find f of -5. -5. So we know that this is, sorry, this is -5 here. This is -5, and this is 1. So we want to find the area under the curves from -5 to 1. And we know, given this, it says it's piecewise linear from -5 to, from x is equal to -5 to x is less than 3, right? And so we know from the interval of -5 to 1 that it's going to be piecewise linear. So we can just basically take the area above or under these curves without using any integrals. We can just take the areas, right? So let's set this up. So we're looking at the integral from -5 to 1 is going to be equal to of g of x, sorry, is going to be equal to f of 1 minus f of negative 5. And we already know that f of 1 is equal to 3, so let's just plug the 3 in right here, right? Is equal to the integral of g of x from negative 5 to 1. Sorry, look, you guys are going to excuse the handwriting today. All right, and so we can calculate, so all we want to solve for f of negative 5. But we can solve for this, right? Because, all right, so let's break this up here. We have triangle here. Oh, let's redo that. Yo, I'm really sorry. I'm not used to doing this. I'm not used to doing this. Teachers, I have to give it to you. I gave you shit in high school, but I'm so sorry. Okay, so we're going to divide this into chunks, right? I see a rectangle here, I see a triangle here, and I see another triangle here. And remember, this is all, since this is an area above the curve, this is going to be a negative area. You can also think of this as this is the portion of the function that's below the x-axis. So this is going to be a negative area, and this is going to be a positive area. So this is going to be positive, and all of this will be negative, right? So let's find our area here. We have from negative 5 until, so we have negative 1, negative 2, negative 2, and this is negative 1, right? So the difference between negative 5 and negative 2, 1, 2, 3. So we have our base is 3, and our height is 1, 2, 3. Just pretend this goes all the way down here, okay? Sorry. This is where the rectangle should end. So we have 1, 2, 3. And if you guys are doing, if you're looking at the practice problem along with me, this is not going to confuse you too bad because you're looking. I suggest that you go here and look, see, because the graph is a lot like easier to follow. You can see that this is 1, 2, 3, and this is 1, 2, 3, right? So it's just easier that way. So you should look at that too. But yeah, I'm sorry if you're just going off this shitty graph right here that I'm drawing. So 3 times 3, we know that the area of a rectangle, right, is base times height. We have a base of 3, and we have a height of 3. And so we have 3 times 3 is equal to 9. But remember, this is the area under the curve, so we'll put a negative 9 here. And now we want to find the area of this triangle, and the base of the triangle is 1, right? Because the difference between negative 2 and negative 1 is 1. And the height is also going to be 3. So we have 3 times 1, and we know the area of a triangle is base times height divided by 2. So we want to do base, which is 1, times height, which is 3, divided by 2, which is going to be equal to 1.5. Because 3 divided by 2 is 1.5, and this is also a negative. So we put negative 1.5. Right. And now this is going to be positive because it's above the x-axis. We have another triangle, right? So we have 2 times 1 divided by 2. That's easy, right? 2 times 1 divided by 2. The 2's cancel. Boom. Boom. We have 1, and this is positive. So now, to get the area, or to get the area under the curve from negative 5 to 1 of g of x, all we have to do is add all these areas that we found. But remember, we have to keep those negatives, right? So we have negative 9 plus negative 1.5 plus 1, which is equal to negative 10.5 plus 1. Keep the sign of the higher number, so it's going to be negative 9.5. So we know that the integral of g of x from the boundary -5 to 1. Now this is just going to equal to -9.5. And now we can solve for f of -5, right? Sorry, my writing's hella slow. I apologize, I do. But it's the best you guys are going to get. All right, so -3, right? This is going to end up to be, so a negative 9.5 minus 3. This turns into a positive. This turns into a negative. So now we have -12.5 is equal to negative f of -5. And now we just, to get rid of this negative here, in front of the f of -5, we just multiply it by -1, which means we have to do it here too. Multiply it by -1. So the -12.5 just becomes a positive 12.5, and this is f -5. I hope that makes sense to everybody. Sorry if I went too fast. I know that these videos have been kind of slow because my writing skills aren't really good. So just let me go if I'm going too fast. Sorry, this might take a second. I'm going to undo the whole thing, except I don't want to get rid of the graph, so bear with me here. Oh, we cannot undo past that. Wow. All right. See, this is what I don't be understanding. Okay, I'm just gonna tediously, sorry. Damn, my computer about to die. That's okay though. We gonna get through this. Sorry, y'all, take a brain break if you need to, because this is hella tedious. I'm sorry, I really am. I don't have any better way to do this. Okay. I'll get rid of this too so we don't get confused, you know. Okay. So we know 12.5 was the answer. Okay, now our second question is evaluate 1 to 6 g of x, right? So we know g of x. We want to get the integral from g of x on the boundary of 1 to 6. So this, here, let me write the red. This is not going to be in red, all right? So the boundary from 1 to 6 would be from here. This is x equals 1 until x is equal to 6, right? And so we know from here that our function is piecewise until x equals 3, right? So we can count the space from x equals 1 to x equals 3 as we can just take the area under the piecewise function. And then when we are getting any time greater than 3, we have to take the integral under the curve. We have to take the integral from the boundary 3 to 6 of this function here, right? So let's first, so we can write this like this. Let's break this up because this is going to be this is part of the points. You have to write this like this. So equals to, you have to break it up because this is your piecewise function part, right? And then you break it up plus 3 to 6 of 2 times x minus 4 to the second power. All right. So this one, let's start with the easier part. So this is just the area of a rectangle. So this is going to be the base is the difference between 3 and 1 is 1, 2. So our base is 2 here, and our height is going to be 1, 2. You can see 1, 2. So 2 times 2. So we know that the area of this rectangle is 4. And so we can put 4 as the integral of g of x from 1 to 3, right? Because we know that's just the area under the curve, which is just the rectangle. Plus, now here's where it gets, we have to do more calculus. So first we want to find, so now we want to find the integral from the boundary 3 to 6 of 2x minus 4 to the second power. Now, of course, we can use we know how to take an antiderivative, so we want to do this divided by 3 from 3 to 6, right? So this will just be a 3. I'm assuming you guys know how to take antiderivatives. But if you don't, I could spend more time on this next time. Oh my god, I can't write the 3. Jesus Christ. I'm sorry, y'all. Okay, so now we just know that this is equal to 2 over 3 times, let's plug in our upper boundary, 6 minus 4 to the third minus 2 over 3. And then our lower boundary is 3, so we plug in 3 for x, 3 minus 4 to the third. And once we evaluate this, we know that 6 minus 4 is just going to be equal to 2, right? 2 to the third power is 8. Make sure you know that. And then 2 times 3 is 16 over 3. Minus 3 minus 4 is -1. And remember, to the third power, the negative stays. So we have -1 times -2 over 3, which is going to just equal to +2 over 3, right? Because those negative signs cancel. And so we have 16 over 3 plus 2 over 3, which is going to equal to 18 over 3, which is simplified to 6. And now we bring this, don't forget about this 4. Now we have to add that. And so all together we get that 10 is the answer, right? 4 plus 6. And we know that 10 is equal to the integral of 1 to 6 g of x dx. And, I guess put your dx, whatever. I'm just kind of trying to show you how to get the answer, the little technical bits. I'm sure you guys know. So, yeah, that's your answer. The integral of the function of g of x from the boundary x equals 1 to x equals 6 is 10. Any questions? No, there's probably nobody on here. Stonks. Good. All right. Let me put. Sorry, y'all. I gotta take another break because I gotta do this again. All right. I just need this bottom portion for this. I want to clear this graph off though, because we're about to be working with it just in a second. All right. I cleared it off as best as I could. I'm sorry. So our next question is going to be for the integral of -5 to 6. So basically the whole graph that we have at our disposal. On what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. Okay, so if f is increasing, so we know that, again, g of x is equal to the graph of f prime of x, right? So we know that when f of x is increasing, when f of x is increasing, then this means f prime of x is greater than 0, right? And this is our graph. This graph of g is our graph of f prime of x. So all we have to do is look where the point, where the graph is above 0. So this whole section, I'll highlight it a different color, put it in brown. This whole section, we just missed that, right? Because this is all below 0. This is all under the x-axis. Now this whole portion here is above the x-axis, so this is fair game. So x is increasing wherever the function is positive. So it's positive all through here, right? This is our positive values. This is our negative values. And so it's positive all through here where the graph is positive. Now, when f of x is increasing and concave up. So to be concave up, this means that the, the derivative of f of x has to be greater than 0, or otherwise must be increasing as well. And we know that this is the graph of f prime of x, basically, right? And so we know when it's increasing because the slope will be positive, or in other terms, the second derivative of f of x will be positive. And so we look at the slope of this line to see where it's positive. It's positive here, right? It's 0 here because it's flat, negative here, and positive all through, positive all throughout here. And these are the parts. See, don't get confused, because the second derivative of f of x and also g prime of x is positive here, but the graph of f of x, it's not increasing, right? So it's not, it might be, so you could say, you might get confused and say, oh, f prime of x is, or the second derivative of f of x is positive here, but the first derivative of f of x is negative here. So the function f of x would not be increasing. Therefore, you can't put that it's both increasing and concave up. Here it's increasing, obviously, because the graph of g of x, which is the derivative of f of x, is positive, right? And it's also concave up because the second derivative, or the slope of g of x, is increasing. So we know that the slope of g of x is increasing from the interval 0 to 1. And it's also increasing from, this is x of 4. I can't even see the cursor. This is 4. So x is greater than 4 and less than 6. That's where that happens. I hope I explained that okay. If I didn't, you can ask me questions, shoot me a message, give a reason for your answer. We already gave the reason, right? This is where f prime of x is greater than 0 and f double prime of x is greater than 0. So this means that, the function f of x is increasing, and this means that the function of f of x is concave up. All right. And now the final question is, find the x-coordinate of each point on the inflection of the graph of each point of inflection on the graph of f. Give a reason for your answer. A point of inflection, this is easy. A point of inflection of a function is where the second derivative, so f double prime of x, changes. So changes from negative to positive, or from positive to negative, right? And so once again, we know we're looking at the second derivative of f of x, right? And if g, our graph of g of x, is equal to f prime of x, then that means the slope of g of x is equal to, so the slope of g of x will be equal to the second derivative of fx, or in other words, yeah, the slope of g of x equals to f double prime of x. So we want to see when the slope of g of x changes from positive to negative. So let's look. Or negative to positive. So here it's 0, right? This is 0. And then it goes positive. Okay, but that's not changing from negative to positive, right? That's going from 0 and upwards. This is 0 again. And now it's going up here, right? Positive. 0 again. 0 to negative. That doesn't count. Negative. Boom. Positive, right? Now it goes from negative here. It's decreasing. Boom, 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 boom. It starts to go up. And so now we can see that at this point, right here, which is x equals 4, that is a point of inflection. So at x equals 4, f of x has a point of inflection. Inflex, I'll just say inflex, but you know what that means. Has a point of inflection. Please do not write inflex, say has a point of inflection. Yes, perfect. Give a reason for your answer. Just say that this is where f double prime of x switches from negative to positive, which is a condition for a point of inflection on the graph of f of x. And there you have it. That's our FRQ question 3. Hi, Karik. That's our FRQ question 3 of AP Calculus, the 2018 exam.